So module 1, unit 1 is about antiderivative. So recall that in your previous calculus course, calculus 1, math 104 or math 151, that course actually dealt with differential calculus. Okay, what you did there is that you started with the concept of limit and simple geometrical idea of the slope of the tangent line to a curve, and we define the derivative as the slope of the tangent line. Try to remember that. And then we develop the idea further into a combination of theories and derivative and their properties, and some techniques of calculating derivative. Lots of derivative formula like power rule, product rule, quotient rule, rule for the exponential function, derivative rule for the logarithmic functions. We did that in calculus 1. On top of that, we apply those concepts to solve problems, particularly from business, economics, and social science. Okay, this section in this course, we deal with the concept of calculus, which is called integration or antiderivative. Okay, so remember, the derivative gives us the rate of change. So for example, if we have a profit function p of x, then the derivative of p of x represented by p prime of x gives us the marginal profit, which means rate of change of the profit. Now in this course, what we do is we do the opposite. So if we are given the rate of change of the derivative, which is the marginal profit or p prime of x, then we'll find p of x. That's all we do. That's the most fundamental concept that we'll be doing in this course: integration, antiderivative. Now let us quickly recall some of the concept, some of the techniques we learned in calculus 1. Suppose you are given a function, f of x equals, let's say, x squared over 2, for example. So what is the derivative of that? The derivative is 2x, right? Now this is what we did in math 104. Now in this math 105, we do the opposite of that, which means integration. Okay, it's antiderivative. Antiderivative. It is called integration as well. So what we do is, the symbol for antiderivative is this s. Okay, s, but it's a stretching s. It's tall s. The s becomes really tall when it comes to integral calculus, you see. And now this one is this, which means you can write this 2x dx. Always the integration sign comes with dx. So remember, this guy right here comes with dx. Then it becomes, it is the symbol for antiderivative. So this must be, we know that this must be x squared over 2 because we just do the antiderivative opposite, right? So what I'm saying here is that we have a function x squared over 2. We found the derivative, this becomes 2x. And when we find the antiderivative, this, not 2x, it's x. It is x. And so this becomes x squared over 2. So when we have x squared over 2, the derivative is x. So the antiderivative of x becomes x squared over 2. Let's say my function is, let's say, x squared over 2 plus 5, for example. What is the derivative? Still the same, right? Because the derivative of the constant is 0. So if I do the antiderivative, I should get x squared over 2 plus 5 in this case. And here it was 0. So this means if there is a constant, the derivative of the constant is 0. Therefore, in order to get the original function, we must have some constant there. So for that reason, we always write c, for example. Okay, c represent a constant. Make sense? So always make sure that you write that c. Now let's do a couple of questions just for fun. Okay, couple of examples. So let's say you are given a function x cubed over 3. What is the derivative? It will be x squared, right? Derivative will be x squared. So that means if I do the antiderivative of x squared, what should I get? I should get x cubed over 3, and depending on what constant we have, what number we have, so I just write c. Let's do one more. Let's say you are given x power 4 over 4, for example. So the derivative will be x cubed, right? Okay, so if I do the antiderivative of x cubed, I should get x power 4 over 4 plus c. Now look at the pattern. Look at the pattern. So when we have 1 there, so we have x squared there and 2 on the bottom. You know, the power is 2 and in the bottom 2. When we have 2 there, so we have 3 here and 3 there. When you have 3 there, we have 4 and 4. If I ask you, if I continue doing that, and if I have my function as xn, then what is the answer for that?
X bar n plus 1 divided by n plus 1.
Excellent. Okay, so this is x power n plus 1 divided by n plus 1 plus c. And this is called power rule. And this is a really powerful rule. Okay, so this is rule number 1. We call it power rule. Okay, now let's try few more. Suppose we are given, let's say x power 7, for example. Can you tell me what is the integration of that? Well, it will be x power 7 plus 8, 1, using that formula over 7 plus 1, which is x power 8 over 8 plus c. That's it. Now, if I give you simply dx, for example, what is that? What is the derivative of this? Remember, if you're, yeah, it means 1 dx, right? So if we are given 1 dx, then this gives me 1 means x power 0 dx, because x power 0 is 1. So that means x power 0 plus 1 over 0 plus 1 plus c. That's going to give me x plus c. Okay, keep that in mind. That's formula number 2. So we have this rule number 1, and now this is our rule. We call it, and just in case if we have 5 dx, for example, then this will be, again, 5 means you can write 5x power 0 dx. So that's going to give me 5x power, 0 means over 0 plus 1 plus c. So that's going to give me 5x plus c. So now what it means is we can write this as 5 dx. So if there is a constant, we can take that constant out. Okay, so we have a formula now. Let's say if we have integration k dx, then we can write k dx. If I want to be more general, I can say that k times f of x, for example, then I can write this as k integration f of x dx. So what I'm trying to say is that if there is a constant, you can just take that constant outside and just find the antiderivative of the function only. Let's try one. If you are given 5x cubed, for example, if you want to find the integration of this, then what that will be? Well, you can take 5 outside and you can write x cubed dx. And now you can write 5x cubed means 3 plus 1, which is 4 over 4 plus c. That's it. So we have already know the formula making process here, right? So now you can check whether your answer is right or wrong. How do you check it? Let's check this here. To check this, what you need to do is do the derivative. Okay, so derivative of 5x power 4 over 4 plus c will be, this will be 20x power 4 over 4, I mean x power cube over 4, plus derivative of c is 0, so that's going to give me 5x cubed. Yeah, that's what it is, as you can see here. All right, so that's how you can check. Now, one thing, suppose if you are given x power negative 1 dx, what happens? If I use this formula, power rule, let's see what happens. Using the power rule, negative 1 plus 1 over negative 1 plus 1 plus c. What is that? It will be x power 0 over 0 plus c. It is undefined, right? This is actually undefined value. Anything divided by 0 is undefined. So the reason here is that when we try using the power rule for this, it didn't work. Now let's think about derivative. Okay, so if I ask you derivative of ln x, for example, what is the derivative of ln x?
1 by x.
1 over x. Thank you. It means you can also say it is negative x power negative 1. You see, derivative of this is x power negative 1. Therefore, antiderivative of x power negative 1 must be ln x. That's the reason, you see. So this is formula number 4 now. So this power rule works for every value of n except n not equals to negative 1. Just keep in mind. Power rule works for every value of n, every real value of n, except one value which is negative 1. So if n is negative 1, then you have to, we have another formula here. Now let's do a couple of things again. Suppose, so you're given ex, for example. Suppose you are given the function e to the x. What is the derivative of e to the x? It's the same, right? E to the x. Therefore, its antiderivative must be the same, e to the x plus c. In the same way, you can develop the formula. If you know the derivative, we have a function, find the derivative, and then you find the antiderivative, you should go back to the same function. So that's how you can actually develop the formula by yourself. Even if you forget the formula, but if you remember the derivative, you can always, come up with the formula. So now let's try a few more. Suppose your function is, let's say, cosine x. What is the derivative of cosine x? It will be cosine x is sine x, negative. If your function is sine x, for example, what is the derivative of sine x? Cosine x. So therefore, antiderivative of cosine x should be, antiderivative of this should be sine x. In the same way, antiderivative of negative sine x should be cosine x. But if I write, if there is a negative sign, then if I want to make it positive, positive sine x, for example, then this positive, then this will be negative. Okay, so that's how you can develop the formula. So here is the list of formula for you guys. Okay, so the formula is constant multiple rule. It's given there. Sum and difference rule. When we have two functions, adding or subtracting two functions, then you can actually put them separately. And this is the power rule we just developed. And we have seen that this power rule works for every value of n except n equals -1. When n equals -1, then the answer, the formula is this. And we also learn constant times, this kx. We discussed that as well. In the same way, if we have e raised to power kx dx, then this will be the formula. If we have e to the x dx, this will be the formula. And all these formula, if you memorize, it will be great. If you don't memorize, you can always create those functions by using the knowledge from your calculus 1. Okay, now let's try. We have a bunch of formula. I believe this handout is already provided in Canvas, so you can actually download it, and you have all these formula at your disposal. So let's try example 1 using those formula. Part A. I believe everybody can give me the answer for this. It will be x power 9 plus 1 using the power rule over 9 plus 1. So that's going to plus c. Don't forget, this is called the constant of integration. This c is called constant of integration. Okay, you must write that all the time. So your answer is x power 10, x raised to power 10 over 10 plus c. Part B. Again, using the constant time function, you can write this as 5 e to the 5x dx. When there is a constant, to make your life easy, you can take it outside of the integral sign. Okay, and so you have 5 there, and this one using the formula. Look at the formula number here, formula number 1 here. E raised to power kx dx equals e raised to power kx over k plus c. In derivative, e power kx, the derivative will be, we copy the same thing and then you'll have k there. So this is the derivative. So that means this coefficient of x will be as a multiplication for that function, right? In case of derivative. But in case of integration, which is opposite, antiderivative, the multiplication will change into division. So therefore, integration e kx dx, it becomes e kx over k. Okay, because derivative and antiderivative are the opposite. So in derivative, it's multiplied by k, and the opposite of multiplication is division. So in integration, it will be divided by k. Just keep that in mind. Okay, so now this one will be 5e raised to power 5x over 5 plus c, and this 5 cancel out, you will get 5x plus c. That's it. Let's try. I will do 2 of these. We did A and B. Now I'll do 2 more and you will do the remaining. Okay, F. Let's see. Let me just copy the question F, which is 2x plus 3 cos x dx. So what we can do is, there is a plus sign, we can actually write 2x dx plus 3 cos x dx. As a matter of fact, when there is a 2, then you may want to write down that 2 outside. So I'll write 2 outside, and so the power rule, using the power rule, we'll have x squared over 2 plus c 1, and this will be 3 integration of cosine is sine x, positive. We have just seen that before, plus c2. So our answer is going to be x squared plus 3 sine x plus c, where c equals c1 plus c2. Now from now onwards, I don't want to write c1 and c2, because at the end of the day, all these constant will be just a constant. So I just write c at the end. Okay, if you want, you can write c1, c2, c3 depending on how many terms are there, but you don't have to. Just a wastage of time. So, but you need to understand that I just write c at the end. All right, now let's look at one question, maybe part E. Okay, one thing, always make sure that if any variable is in the denominator, bring it to the numerator. If the variable has some radical sign, let's say you have this, always change into power, because we are going to use the power rule. Therefore you need to change that in a nice power. Okay, so here it is 1 minus, this will be 3x power negative 1 plus x power negative 4 dx. You can put them separately, but that just it just takes a lot of time, so we want to save time here. So integration of 1 dx, remember we already discussed that integration of 1 dx is simply x. That is formula number whatever, 1 2 3, you check that. So this integration of 1 dx is simply x minus 3 integration of x power negative 1. We have formula, we just developed that formula, which is ln x. Make sure that you write this absolute value with this x, because ln, if it is negative, let's say negative 2 for example, it doesn't make any sense. Okay, the domain for logarithm is always positive x. So in order to make this positive, you must write absolute value sign. I think you already know this from your calculus 1 course. Plus this guy will be x raised to power negative 4 plus 1 divided by negative 4 plus 1, and I just write c at the end. Now from this example, remember, always change whatever the variable is given, change it in such a way that you will see the power clearly, so that you can use the power rule. Sometimes you'll be given like x like this. Okay, so you need to change that into the power. So your final answer is going to be x minus 3 ln x. This will be minus, it will be this is x power negative 3, so x power negative 3 over over 3 plus c. You can leave it like that, but generally speaking, the mathematical convention is that if there is a negative power, we tend to change it, we tend to convert it into positive by doing this. Okay, so you don't have to do it, but this is always good to do this. Now, checking part, actually, it's the question tells us to find the, to use, evaluate the integral by using the formula and check your answer by differentiating. I forgot to check each of these, but I trust that you can do it. But let's try this one. Okay, let's check this, and I leave others to check on their own. So checking. If we differentiate this, then we should be getting this. Let's try. Derivative of x is 1 minus 3. Derivative of ln x is 1 over x minus derivative of this. Okay, so derivative of this is 1 over 3x cubed, which means derivative of 1 over 3 x negative 3. So this will be negative 3 x negative 4 over 3. 3 cancel out. We're gonna get negative x power negative 4, which means 1 over x power 4. So this is what we got, is we got negative 1 over x power 4 plus derivative of c is 0. So we got 1 minus 3 over x, negative and negative will be positive 1 over x power 4. Is this the same thing that we started with here? You see, they are the same, right? So our answer is correct. That's how we can check. Right, so for part D, this is what we got. And checking part, I trust that everybody know how to check it, how to find the derivative, and I leave it to you. So part Z also, I think you can do in the same manner. You know the formula because the formula is already provided for sine x there, but if you forget the formula, you can derive the formula. So far what we learn is that we learn formula making process. Okay, if we know the derivative of a function, then we know the integration, we know the formula for the integration as well. It's just the reverse process. So I leave it to you. Now let's look at example 2. Find the function f such that f prime of x, the derivative is given, and it is called initial value is also given. It is called initial value problem. So are you ready for example 2? Okay. Now find the function f. The derivative is given and we want to find the original function. So how can we do that? Well, So we know that f of x equals always the antiderivative of the derivative. We know this. Right? We know this. Now, what it means is this is x squared dx. So this means x cubed over 3 plus c. Now, the c is constant of integration. We don't know the value yet. But remember, in the previous example, the condition, the initial value is not given. Okay, initial value were not given. None of the questions have this condition. But now we have the condition. Whenever the condition is given, we will be able to find the exact value of c. Okay, so let's say this is my function f of x. And to find the value, the condition given is that given f of -1 equals to 2. What it means is when x equals -1, your f of -1 equals 2, that is given, right? Your f of x is 2, that is given. So I can substitute the value here, which is substituting this value there. So what I get here is 2 equals x cubed over 3 plus c. Now x means -1. So I'll write -1 cubed over 3. And if we simplify it, okay, if we simplify, so you're going to get 7 over 3. Therefore, substituting the value, substituting value of c in 1, in equation 1, so we get our function to be x cubed over 3 plus 7 over 3. That's it. So example 4 is, suppose the marginal, this is an application of integration, the skill that we have just learned, application in economics, okay? Suppose the marginal revenue of a company from a product is given by r prime of q equals 100 e raised to power negative 0.1 q plus 10, where q is the number of product produced. Find the revenue function for the product and find the demand function for the product. Okay, first of all, let us find revenue function. So to find the revenue function, we know that revenue function r of q equals antiderivative of the derivative function r prime of q dq, which is given by integration of 100 e raised to power negative 0.1 q plus 10 dq. So this means 100 we can write outside, and using the rule that we have discussed earlier, so this will be e raised to power negative 0.1 q over negative 0.1 plus 10q plus c. So this looks a little ugly, right? So what we can do is we can write it in a nice way. So that's going to give me, therefore, r of q equals 100 divided by 0.1 becomes, I think, 1000, right? So I can write this as negative 1000 e raised to power negative 0.1 q plus 10q plus c. So this is our function, revenue function. But now the question is, how do we find the value of c, right? So in the previous example, example 2 and 3, we were given the initial value condition clearly, explicitly. But without the condition, we cannot find the value of c. Let me repeat this. To find the value of c, initial value must be given. In another word, some condition must be given, as in example 2 and 3. Now, my question to you is this. Can we find the value of C? Is the condition given here in this example 4?
No, the condition is not.
Okay, now that's the tricky part here. Remember, even though the condition is not given, sometimes we can use our common sense and figure out what is the condition. Okay, so here, can I say that, okay, let me write, even though the initial value is not given explicitly, we can still say that revenue of 0 equals 0. Can I say that? When you sell 0 product, your revenue will be 0. It's safe, right? It's just the common sense. We already know that. Even though the initial condition is not given, but this one is just a common sense. We can use it. So if I use this, then substituting this value, substituting in 1, we get 0 equals negative 1000 e raised to power negative 0.1 q plus 10 q is 0. Okay, this one is negative 0.1 times 0 plus 10 times 0 plus c. And if you solve it, what is the value of c? I believe your c is 1000. Is that right? It is because 0 equals, this is going to be negative 1000 e raised to power 0, which is e raised to power 0 is 1. This is 1 plus c. So this is going to give me c equals 1000. All right. So now substituting this value in 1, substituting value of c in equation 1, we get revenue function equals negative 1000 e raised to power negative 0.1 q plus 10q plus 1000. Okay, this is our revenue function. Part A is done. Now part B. Is there any question, guys? Okay, now let's try part B. If you don't have any question, let's try part B. So in part B, what we want to do is find the demand function for this product. Demand function. What is this demand function? Well, we know that price times quantity equals revenue, right? We know this. So P times Q equals R of revenue. So that means, remember, demand function is either you can write price equals R over Q is a demand function, or you can write Q equals R over P is also a demand function, okay? So you can choose whichever functions you want to consider for demand function. Both represent the demand function. Price and quantity represent the demand function. So in this case, because the function is function of Q, I think to make life easy, what we can do is demand function in terms of P will be easy. So demand function P equals R over Q. So R over Q means R is 1000 e raised to power negative 0.1 Q plus 10Q plus 1000 divided by Q. You can just leave it like that. So, some in the past, people, sometimes students think that when we say demand function, we must express in terms of Q. That's not true. We can express in terms of Q, in terms of P. Either one is fine. No issue there. Okay.